Imagine for a second that you are stepping into the role of a Formula One team principal. You are handed a war chest of 150 million euros.
Right, which is the absolute maximum permitted under the sport's strict budget cap.
Exactly. You have the maximum amount of money legally allowed, and you use that capital to aggressively recruit the most legendary aerodynamic designer in the history of motorsport.
Adrian Newey.
Right, Adrian Newey. And then you secure this exclusive factory-level partnership with a world championship-winning engine manufacturer. On paper, you've engineered the ultimate dream team.
You've done everything perfectly.
You really have.
But yeah.
And yet, when the cars actually hit the track, you realize you have built one of the absolute slowest, most undrivable machines on the entire grid.
It genuinely feels like this cynical thought experiment about the limits of money in sports. But for the Aston Martin team, I mean, this is the brutal waking reality of their 2026 season right now.
They have hit a wall that money alone is completely failing to dismantle.
Yeah.
So welcome to our deep dive. Our mission today is to just, pull apart this catastrophic start to Aston Martin's season.
And we really need to examine the high-stakes, all-or-nothing rescue plan they're attempting to execute. Because it is wild.
It is. We are pulling insights from internal technical analyses of their AMR26 chassis today, along with deep engineering briefings focused on that struggling Honda power unit. Plus, we've got strategic timelines mapping out the upcoming European leg of the calendar.
We are getting into the absolute mechanical and political guts of this crisis, because the pressure inside their Silverstone factory, it is reaching a boiling point.
Oh, absolutely. But before we even analyze the architecture of their proposed rescue plan, we need to establish for you listening the sheer scale of the crater they're currently sitting in.
Yeah, let's look at the numbers. Aston Martin is currently second to last in the Constructors' Championship.
With a single point.
One solitary point. Scraped together from a 10th place finish in Monaco.
And for a listener tuning in, you might think, a one-point season is a symptom of a chronically underfunded backmarker team.
Yeah.
But this is a juggernaut operation.
Exactly. And Fernando Alonso, a two-time world champion who is famously intolerant of uncompetitive machinery, he has completely abandoned diplomacy.
Oh, he hasn't held back at all.
No, he's telling the global press they have the worst car and the worst motor in the field. He is essentially driving a €150 million anchor.
And the timing of Alonso's frustration is alarming because their immediate, unavoidable hurdle is the Austrian Grand Prix.
Right, the Red Bull Ring.
Yeah, it's the very next race. And it is a circuit seemingly custom-built by the racing gods to expose every single structural flaw this current Aston Martin possesses.
It really is. Let's break down why Austria is such a nightmare for them. It's a very short lap, barely a minute long, with, long straights and heavy braking zones.
But the layout isn't the real enemy here, is it? It's the geography.
Exactly. The track is nestled in the Styrian Mountains, sitting at an elevation of roughly 700 meters.
Which is high for F1.
It is. Think about circuits like Madrid at 697 meters, or Interlagos down in Brazil at 765 meters. Altitude is the natural enemy of any combustion engine.
Because the air density drops significantly.
Right, and it is particularly devastating to a turbocharged Formula One power unit.
Because under the previous generation of regulations, teams had a technological loophole for thin mountain air, right? The MGUH.
The motor generator unit heat, yes.
It was an electric motor attached directly to the shaft of the turbocharger.
And it was magic for high altitude, because even when the exhaust gases were too weak in the thin air to spin the turbo up to speed naturally, that electric motor could artificially force the turbine to spool.
Right, cramming oxygen into the engine and completely masking the effects of the altitude.
But the 2026 rule changes completely eradicated that safety net.
Yeah, the FIA removed the MGUH entirely in an effort to simplify the power units and, attract new manufacturers.
So now the turbocharger is completely mechanical again. It relies exclusively on the pressure of exhaust gases to spin.
And in the thin air of the Austrian Alps, that turbine has to spin exponentially faster.
It's working brutally hard just to harvest enough oxygen for combustion.
So if I'm translating the internal engineering briefings we have from Honda, the engine is already anemic at sea level.
Right.
Asking it to perform in Austria without the MGUH is the mechanical equivalent of asking a marathon runner to sprint uphill while breathing through a plastic straw.
That analogy captures the thermal reality perfectly. Because the turbo is overworking just to find baseline oxygen, it generates massive, unsustainable levels of heat.
Oh, wow.
Yeah, the internal data indicates they are facing a severe power deficit coupled with a critical cooling crisis. I mean, Aston Martin's going to burn through their entire first practice session just trying to open up the bodywork enough to stop the Honda unit from cooking itself from the inside out.
Which naturally leads to a massive contradiction in the data we're seeing.
What do you mean?
Well, think about it. If the Honda engine is gasping for air and severely lacking straight-line speed, why are the drivers, especially Alonso, constantly fighting the car through the corners?
Ah, right.
Because an underpowered car is usually quite stable, right?
Right.
It isn't stressing the aerodynamics.
Generally, yes.
So there has to be a physical link dragging the handling down alongside the power. What's connecting these two failures?
You've identified the central nervous system of the problem. It's the gearbox.
The gearbox.
Yeah. To grasp why Aston Martin is failing so comprehensively, we have to look at how a modern Formula One car is physically constructed. A gearbox in F1 is not just a metal casing holding gears.
No, it's a vital load-bearing structural component.
Exactly. The entire rear suspension architecture, the wishbones, the pull rods, they bolt directly into the titanium casing of the gearbox.
Meaning the physical shape and layout of your gearbox dictates the geometry of your rear suspension.
Precisely. If you buy your gearbox from a manufacturer like Mercedes or Ferrari, which is what teams like Williams, McLaren, or Haas do, you are locked into whatever suspension kinematics Mercedes or Ferrari designed for themselves.
You trade aerodynamic freedom for guaranteed reliability and cost savings.
Right. But Aston Martin decided that to win a world championship, they could not be beholden to Mercedes' design choices.
They wanted absolute freedom to shape the airflow over the rear of the car.
So for the 2026 regulations, they took on the staggering engineering challenge of building their own bespoke gearbox from scratch.
Ambition is great until the reality of hybrid integration sets in, though.
That's the kicker. A gearbox in this era isn't purely mechanical. It's a digital hub. It has to constantly communicate with the hybrid power unit.
And the internal data shows that this bespoke Aston Martin gearbox and the Honda engine are speaking two completely different digital languages.
It is a total miscommunication, and it happens at a very specific, highly vulnerable moment.
When the car decelerates below 40 kilometers per hour.
Yes. At that speed, the hybrid system engages the MGUK, the kinetic motor, to aggressively harvest energy from the rear axle to recharge the battery.
Instead of using the physical carbon brake pads to slow the car, the system uses magnetic resistance from the electric motor.
Exactly. It's regenerative braking, like you have in a consumer electric car, but happening at mind-bending speeds and forces.
But when that Honda engine tries to initiate that heavy harvest, the digital handshake with the Aston Martin gearbox completely fails.
The gearbox control unit just doesn't anticipate the massive torque demand, so you get an instantaneous, violent spike in magnetic resistance on the rear axle.
And the tires only have a finite amount of mechanical grip.
Right, and that sudden spike shatters that limit. The rear wheels literally stop turning. It's called rear locking.
For you listening, think about your laptop or phone freezing when an app fails to communicate with the hardware.
Yeah, the spinning wheel of death.
Exactly. Now imagine that system crash happening to the rear wheels of a car while you are trail braking into a hairpin corner at 100 miles an hour.
It acts like an unpredictable electronic handbrake.
And that exact desynchronization is what threw Fernando Alonso into the barriers in Monaco. The driver expects a smooth deceleration curve, and instead the car violently snaps.
It's terrifying. And internally, it's chaos. The chassis department is pointing fingers at the engine mapping, the engine department is blaming the gearbox software, and the driver is left entirely without confidence, just waiting for the car to bite them.
You cannot fix a flaw that deeply embedded with a minor aerodynamic upgrade.
No, you can't just bolt on a new front wing and hope the digital architecture magically synchronizes.
Which brings us to the rescue mission.
The AMR26B.
Yeah, the internal documents outline the deployment of this B-SPEC car. They're not just tweaking the car, they are preparing to introduce a fundamentally new machine mid-season.
And hitting the reset button like this is an immense logistical gamble.
Huge. The factory initially targeted Silverstone or Spa to introduce this car, right?
Right, but the manufacturing lead times for a completely new chassis forced them to shift the deadline to the Hungarian Grand Prix.
Which sits perilously late in the calendar. I mean, Hungary is the penultimate race before the mandatory 2-week summer factory shutdown.
Delaying until Hungary grants the manufacturing side 3 vital extra weeks to produce the carbon fiber parts.
But it creates an absolute do-or-die scenario for the engineering team. They must validate this new car before the summer break. Look, I want to push back on this strategy for a moment, because for anyone who has ever fallen victim to the sunk cost fallacy, pouring more resources into a failing project, hoping it will eventually work, this looks terrifyingly similar.
It does look like a massive panic button.
Right. And Aston Martin has a notorious recent track record with upgrades. In 2023, they brought massive packages to Canada and Zandvoort. In 2024, they overhauled the car for Imola. And in almost every instance, the upgrades actually destroyed the car's balance and made them slower.
Yep.
So aren't they being incredibly reckless by rushing a €150 million redesign onto the track in Hungary? What if they just introduce another flawed package?
It is the definition of reckless necessity. You mentioned the sunk cost fallacy, and executives are certainly losing sleep over it. The core issue has been a persistent failure of correlation.
The wind tunnel data not matching reality.
Exactly. The aerodynamic data they see in their state-of-the-art wind tunnel simply does not match the physical reality of the car on the asphalt.
But they can't stay with what they have.
No, however bad the upgrade might be, they cannot keep running the current iteration. It is fundamentally unsafe and uncompetitive.
And if they delay past the summer break, the validation calendar becomes actively hostile to untested machinery.
That's the real tyranny of the calendar here. Look at the sequence of races post-summer. First is Zandvoort in the Netherlands. This year, Zandvoort is a sprint race weekend.
Oh, brutal.
Yeah, the teams are granted exactly one 60-minute practice session before the cars are locked into Parc Fermé conditions.
And once in Parc Fermé, it is illegal to change the suspension geometry or the aerodynamic setup.
Right, so if you roll a brand new, completely untested B-SPEC car out of the garage and your baseline setup is off by even a millimeter.
Your entire weekend is over after 1 hour.
Over. You are trapped in a bad setup for both the sprint and the main Grand Prix. It's competitive suicide.
And it doesn't get better after that. Following Zandvoort is Monza, the Temple of Speed, which demands a bespoke, ultra-low downforce rear wing.
Yeah, so you learn absolutely nothing about your car's baseline aerodynamic efficiency at Monza. It's an outlier track.
Then they head to the brand new street circuit in Madrid.
Zero historical data. Zero track evolution models.
Followed by Baku, which introduces the logistical nightmare of freighting brand new, unproven carbon fiber across the continent.
If the AMR26B does not prove itself in Hungary, they will be flying blind into the hardest stretch of the season.
So they're forced to push their chips to the center of the table in Budapest.
They are, but unlike their failed upgrades in 23 and 24, they now possess the ultimate trump card in motorsport engineering.
Adrian Newey, the most successful aerodynamicist to ever draft a Formula One car.
Exactly. Newey, alongside technical director Enrico Cardile and chief designer Duncan Elliott, is orchestrating open-heart surgery on the AMR26.
Based on the internal technical blueprints, they're replacing nearly every aerodynamic surface on the car.
The only major component surviving the call is the front suspension.
They are keeping the front suspension, but entirely redesigning the rear, which connects directly back to the gearbox crisis we discussed earlier.
Precisely. The entire theoretical advantage of building a bespoke gearbox is the freedom to dictate your rear suspension points.
And Newey is finally weaponizing that freedom.
He is completely overhauling the rear suspension geometry to mechanically force the rear tires into the tarmac.
Wait, so he's trying to create so much mechanical grip that even when the Honda engine violently desynchronizes and spikes the torque,
the rear axle will not lock.
That is a staggering approach. He is utilizing pure mechanical engineering to overpower a catastrophic software bug.
It's brilliant. And this perfectly aligns with an insight into Newey's methodology shared internally by Pedro de la Rosa, who worked alongside him at McLaren. Newey doesn't just blindly trust digital simulations, he engineers for the human driver.
Right, because CFD, computational fluid dynamics, is the digital wind tunnel that teams rely on. But CFD and physical wind tunnels have severe limitations.
Huge limitations. A wind tunnel blows air over a static car. It struggles to replicate the dynamic yaw, pitch, and roll a car experiences when a driver throws it over a curb.
And De La Rosa highlighted this flawlessly with a story from 2005. He was testing the McLaren MP420 and suffering from terminal understeer. The front tires just wouldn't grip into the corner.
Most modern engineers would look at the wind tunnel data, which said the car should turn, and just tell the driver to change his driving style.
Because in a wind tunnel, they typically only test the car with the wheels turned to a maximum of 6 degrees.
But Newey bypassed the algorithm. He didn't look at the screen. He looked at De La Rosa's steering inputs on the track.
He measured that De La Rosa was having to crank the wheel far beyond that 6-degree limit to force the car to bite.
Right. So Newey took out his legendary notebook, went back to the drawing board and designed a custom front wing specifically to generate downforce at those extreme, real-world steering angles.
He cured the understeer overnight by listening to the physical reality of the human, not the theoretical perfection of the computer.
And that is the exact pragmatic genius Aston Martin is banking on to fix this rear-locking nightmare.
But while NEWEY attempts to manually correct the chassis, Honda is taking an equally desperate high-risk gamble on the internal combustion side.
Because a perfect chassis is useless if the engine cannot breathe.
Exactly. The 2026 ADU regulations, the approved development updates, severely restrict engine evolution. Manufacturers are granted only 2 upgrade tokens for the entire season.
Usually an engineering team mitigates risk by splitting them up. Update the combustion chamber early in the season, see how it interacts with the hybrid system, and then deploy the second token on the turbocharger months later.
But Honda is abandoning caution. They are deploying both of their development tokens simultaneously in Hungary.
It is a massive coordinated upgrade aimed at one single obsessive metric: pure horsepower.
Wait, are they completely ignoring the cooling and vibration issues that are causing the engine to fail in the first place?
The internal documentation suggests they are actively prioritizing performance over reliability.
That's insane.
I mean, Honda has already burned through $8 million and 190 supplementary test bench hours attempting to cure the violent harmonic vibrations tearing the current engine apart.
And the result was an engine that was both fragile and slow.
Right. So they're pivoting to the strategy Ferrari famously employed in 2022.
The fast grenade philosophy.
The fast grenade. It is a brilliant exploitation of the FIA homologation rules.
Explain that for the listeners.
So the regulations state that you cannot upgrade an engine mid-season to make it faster. That's frozen. However, you are allowed to petition the FIA to make modifications for the sake of safety and reliability.
Right, so the strategy is to build an absolute rocket ship of an engine fully knowing it might vibrate itself to pieces or catch fire.
Exactly. You burn it down if you have to. But once it proves it has the raw horsepower on track, you go to the governing body and ask for permission to reinforce the internal components so it stops exploding.
Because you can engineer reliability into a fast engine, but you can almost never engineer speed into a slow, reliable engine.
Bingo. Honda is rolling the dice. They want to show up in Hungary with an engine that finally delivers the lap time. If it detonates a few races later, they will deal with the paperwork then.
Okay, when we synthesize all of this NEWEY'S mechanical workaround, the aerodynamic overhaul, Honda's dual token hand grenade, we have to ask a grounding question here.
Which is?
Is it actually physically possible to bolt on a package in Hungary that finds the 2 to 3 seconds of lap time they're bleeding to the front runners? I mean, 3 seconds is an eternity in F1.
Right. And to set realistic expectations, no. Finding 3 seconds of raw pace overnight in modern Formula One violates the laws of physics.
So it's not a silver bullet.
No. They are not going to arrive in Budapest and suddenly stick Fernando Alonso on pole position. The definition of success for the AMR26B is entirely about trajectory.
They need consistency.
They need a car that Alonso can brake heavily into a corner without fearing the rear axle will seize. They need to consistently qualify in the top 10 and score reliable points.
And most crucially, they need to prove that when Adrian Newey designs a part in the digital realm, it actually works on the asphalt.
Yes, they have to prove to their investors and to their drivers that the correlation crisis is over.
Which makes the upcoming Hungarian Grand Prix so much more than just a race. It is a brutal public exam of the entire Aston Martin infrastructure.
They are testing their state-of-the-art factory's manufacturing speed. They are testing this newly assembled super team of aerodynamicists.
They are testing Honda's willingness to push the regulatory limits.
And they are testing whether a bespoke gearbox was a masterstroke of ambition or a €150 million act of hubris.
Because if the B-SPEC car rolls out of the garage in Budapest and the rear wheels are still locking, the fallout will be catastrophic.
It threatens the commercial viability of the entire project.
And it fundamentally threatens Alonso's tenure. A generational talent will not spend his twilight years wrestling a broken digital prototype around the midfield.
He just won't. The survival of the entire endeavor hinges on these few weeks of development.
It really leaves you with a fascinating, almost unsettling thought about the state of modern motorsport. For you listening, consider the sheer scale of the resources at play here. You can possess functionally limitless capital.
€150 million.
Right. You can hire the undisputed greatest engineering mind in the sport's history. You can place a 2-time world champion in the cockpit. And yet, the entire empire can crumble simply because a hybrid electric motor fails to properly execute a digital handshake with a gearbox when the car slows down.
It's staggering when you put it like that.
How the technical regulations of Formula One become so deeply opaquely complex that they are actually suffocating raw human engineering. If Adrian Newey has to physically bypass the data just to make a car corner, perhaps the computers have finally gotten in the way of the racing, something for you to mull over until our next deep dive.